All right, so section 1.2, the product and the quotient of powers. So once again, powers means exponents. So we're talking about the product, which means multiplication, and the quotient, which means division, right? So product means multiplication, and quotient means division. We're talking about what happens when you multiply and divide numbers that have exponents. So 5 times 5, right? Let's write this down first. Don't worry about what's up there. So 5 times 5 is 25. But also, if we're doing prime factorization, and you got an answer of 5 times 5, if I told you to write this as an exponent, you would write 5 squared. Because there's two 5s, 5 is the base, 2 is the exponent. Because I only see one 5 here, it's 5 to the first power. A little trick I'll teach you now. If you don't see an exponent, you always give it a 1. Here, because there's only one 5 here, the exponent is 1. So technically you're doing 5 to the first times 5 to the first, and you're getting 5 to the second. Now a lot of kids think that you're multiplying the exponents, but think about it. Isn't 1 times 1 just 1 and not 2? So what are you doing to 1 and 1 to get 2? You're not multiplying. Instead, you're adding. Because isn't 1 plus 1 2? When you're multiplying the same number, the same bases, technically you add the exponents. Now I'll go ahead and do their example here, but you'll see exactly what I mean. They're saying a to the fourth times a to the third. What they want you to do, this is the longer way, so you're only doing it now one time, but you're not doing this ever again. The longer way, that is. The first thing I want you to do is to expand. So a to the fourth means that there's 4 a's, right? So it's a times a times a times a. And then we're going to expand a cubed, which is a times a times a. And then we're just going to write this as an exponent. Well, obviously a is the base, but how many a's do we have now? We have 1, 2, 3, 4, 5, 6, 7. So the question is, how can I avoid this step and go straight to my answer? Well, very simple. A to the fourth times a to the third, a to the seventh, right? Technically what you're doing is, even though it does say multiplication, because once again, when you multiply the same bases, right, these have to be the same, just like 5 and 5 are the same, a and a are the same. The rule is, when you multiply the number with the same bases, technically you add the exponents. 4 plus 3 is 7. And that's why the answer is a to the 7th power. So what can you conclude about multiplying powers with the same bases? When you multiply powers with the same bases, you're going to add the exponents. Please understand that the bases have to be the same. Always read the directions because we might be doing more work than we have to. The directions. Use the product of powers property to simplify numerical expressions. The end got cut off. So here we're just going to write our answer as an exponent. We don't need to solve it afterwards, which is good. So 3 to the 6th power times 3. Once again, you always want to compare an apple with an apple. One number has an exponent, the next number does not. You want them both to have exponents. If you see a number not have an exponent, always give it that invisible 1. So technically it's 3 to the 6th power times 3 to the 1st. Because the 3's are the same, because the bases are the same, and because you're multiplying, technically what you do is you add the exponents. And 6 plus 1 is 7. I keep the base the same. That's another thing kids do. They do 3 times 3, which is 9. No. If the bases are the same, you leave it the same. It's going to be 3 to the 7th power. I'll erase all this. I'll put a 1 here again. I'll leave the 3 alone. I add the 6 and the 1, and I get a 7. My answer is 3 to the 7th power. Done. Here, because it has parentheses, make sure your answer has parentheses. We might have to do an extra step afterwards. I'll go over what that is in 1 second. So here, first check, are bases the same? If they are, and you're multiplying, you can use this shortcut. The shortcut is you can add the exponents. So let's first write down our base. Leave the base alone. So it's still -4 inside the parentheses. But now I'm going to add my exponents. And 2 plus 4 is 6. Now this is the part that gets tricky. technically, right? Oh, the math is always technically. This answer is a positive number and not a negative. And I'll explain better why. So I think everyone understands that it's negative 4 6 times, right? Don't worry about the 4s. I really have to focus on just the negatives. A negative and a negative, right? When you're multiplying, a negative times a negative is a positive. A negative and a negative is a positive. And a negative times a negative is a positive. In short, if your exponent is even, and 6 is an even number, technically, even though the base is negative, it becomes a positive. Once again, technically, even if it looks like a negative, because the negatives cancel each other out because the exponent is even, it becomes a positive. And my answer is really 4 to the 6th power without the parentheses. If you want to put it with the parentheses still, please understand I'm marking it right. But you're not supposed to have the negative in there because the negatives cancel out because you had an even exponent. Well, what happens if you had an odd exponent, right? Let's just say it was negative 3 to what? We'll make it somewhat easy. Let's say to the 5th power. Don't worry about the 3 part. Just worry about the negative, right? That means that there's 5 negatives. 1, 2, 3, 4, 5. A negative times a negative is a positive. A negative times a negative is a positive. But look, you have 1 negative left over. That means in this problem, the answer will actually remain, parentheses, negative 3 to the 5th power. Here the negative does not disappear, and that's because the 5 here was odd. Pause, do these 3 on your own, call me over when you're done. Right? This number doesn't have an exponent. Please give it an exponent. It also has parentheses, so be careful with that. Remember the odd and the even exponents. Okay. Example 8. So z to the 2nd times z to the 6. Bases are the same. I add the exponents, so it's z to the 8. You can do it with or without parentheses. It doesn't matter. Here, it's negative b with parentheses. Here, I need the parentheses. And because I'm multiplying the same base, I add the exponents. 3 plus 5 is 8. I'll slow this part down, though. The 8 is even. That means that there's 8 negative symbols. Because there's an even amount of negative symbols, right? 1, 2, 3, 4, 5, 6, 7, 8. Negative times a negative cancels out everything here. The negatives cancel out. You don't have a negative anymore. So technically my answer is b to the 8th power. If you do b to 8th power, you can either do it like this or like this. They're both correct. But there is no negative symbol because your exponent was an even exponent. 2x doesn't have an exponent, so I'm going to give it exponent. Put a little 1 there. And everything else is the same. My bases are the same, 2x and 2x. So I can leave it the same, leaving it as 2x with the parentheses. And then I'm going to add my exponents. 3 plus 1 is 4. Go ahead and do the guided practice on your own. Okay, example 9. This is where kids kind of get confused because sometimes you see a multiplication symbol, sometimes you don't. Remember, multiplication is very unique. It's the only operation that you don't technically have to see it for it to be there. I'll give you an example. 8 times 6. You don't see an operation there, right? And once again, if you don't see an operation, it always implies multiplication. So in the past, right, I had you guys put like a multiplication symbol in there. It's the same thing here. Right? I get how there's a multiplication symbol right there, but technically, it's b squared times c cubed times b to the 5th times c to the 5th. There's actually a multiplication symbol in between the b and the c as well. So just keep that in mind. From here, it's just as simple as just combining like terms in a sense, right? Just focus on your b's first. You're multiplying the same base, so technically you're going to add the exponents. So it becomes b to the 7th power. Done and done. And then do your c's. Technically you're multiplying the same base, so add your exponents. And 3 plus 5 is 8. Now some of you are going to do this. B to the 7 times c to the 8. And that's technically correct. Like, I'm going to mark it right. Simpler is better. So if I don't need a mathematical symbol there, I'd rather not. Right? That's why in math we call things like simplified. Like sometimes we can't solve it, but the directions will tell you to please simplify it. Even though this answer once again is correct, you can probably understand why this is simpler. B to the 7th, c to the 8th. Maybe they look identical to you, maybe not. But understand that here, I have a multiplication symbol, and here I don't. This is the better answer because I have less symbols. We only put symbols in when we need them. If we don't need them, we shouldn't be putting them in. Multiplication is, once again, one of the few operations that you don't need to see it for it to be there. So once again, b to the 7th, c to the 8 is the better answer. Okay, so for letter B, remember what I said before. If you don't see an operation in between them, it implies multiplication. This time though, I'm not going to have you put a multiplication symbol. If you want to, listen, go ahead. Put a multiplication symbol there, here, there, and there, right? If you're visual and that just helps you separate them, go ahead and do it. Some of you, I don't think, need it, so don't do it if you don't need it. So the first thing is, I'm doing the 2 times the 3. They're both called coefficient numbers. That means that they're big numbers. Now you can't do the shortcut here because 2 and 3 are different bases. So because you can't do the shortcut, just solve it. What is 2 times 3? 2 times 3 is 6. I always get a student tell me, well, don't you add them? You just went over how you have to add it. No, you add the exponents, right? Exponents are these small little font numbers here. These are the little guys that you're adding. Notice how 3 and 2, notice how the font's much bigger. Once again, they're called coefficient numbers. So you never add coefficient numbers when you're obviously multiplying. And then also another thing too, right? They have to be the same base. So you have to understand when you can do the shortcut, you also got to understand the difference between a coefficient number and an exponent. So 2 times 3 is 6. You're not adding, you're multiplying. Now I'm going to focus on the x's. Here, the x's obviously have the same base. They're both x's. So the exponents, these small little guys here, I'm not going to multiply them. I'm going to add them. And 4 plus 2 is 6. So my answer is x to the 6th power. Then I can focus on my y's. Same thing as before. The y's obviously have the same base. They're both y's. So I don't multiply the exponents. I add the exponents. The exponents are these small little guys right here. And 2 plus 6 is 8. So it's y to the 8th power. I don't need to put multiplication symbols in between each of the letters, right? If I don't see it, it already implies multiplication. So 2x to the 4th, y to the 2nd, times 3x squared, y to the 6th, is 6, x to the 6, y to the 8. So it looks overwhelming at first, right? You look at this, you're like, oh my god, I can't do this. But just understand what you just did here. You just took it one number at a time. You first did the coefficient numbers, those are the big numbers. Then you did the x's, and then you did the y's. You technically did 3 problems in one, but if you separate it, it's not that hard. And then just put it all together afterwards. Try these 2 on your own. Just one thing I'm noticing that I want to just go over quickly with this one, but I will not solve it for you. With number 7, remember it's p times q to the 3rd times p to the 5th times q to the 2nd. Here I'm putting multiplication in between so I can just see it better. That p does not have an exponent. A lot of kids thought that the 3 is for the q and the p, and it's not. The 3 is just for the q. The p doesn't have an exponent, so just make sure you give it that invisible 1, and then solve it from there. Understand the quotient of powers property. So, quotient means division, right? So let's think about it. When you multiply the same bases, technically you added the exponents. So when you divide the same bases, technically, what do you think you're going to have to do? Hopefully you said subtract. I'll go over why that is, and then we'll do some problems together. So let's just say it was 5 to the 3rd power divided by 5 squared. Actually, before I even do anything, in your textbook, they do it like this. They do 5 to the 3rd power divided by 5 squared. If you can, I would like you to get better at writing it like this, top to bottom instead. So the first thing you do is this division symbol, just put it as a fraction bar instead. The number that you read first, like a book, so the number that you read to the left, this number always goes on top. It has nothing to do with size. I don't care if it's bigger or smaller. The number that you read first always goes on top. So 5 to the 3rd is on top, and then the number you read after the division symbol always goes on the bottom. This will make your life 10 times easier moving forward. And I'm not even saying moving forward in my class. I'm talking about moving forward in any of your math classes. So next year when you're in high school and you're doing Algebra 1, this will help you. Get better at using it as a fraction symbol instead of a division symbol. So now I'm going to solve 5 third over 5 squared. I'll first do it the long way. This way I don't expect you to do it moving forward. So 5/3 means that there's 3 5s. 5 times 5 times 5. 5 squared means that there's 5 times 5. Off topic, let's think of your comp packets. Let's just say you're doing 1/5 times 5/9, right? Remember the whole simplify before you multiply? Remember how if you had a 5 on the bottom and a 5 on top, you can cross them out? Same thing here. You have a 5 on the bottom, you can cross out with the 5 on top. I like to put a 1 there and a 1 here. The only reason why I like to do that is because sometimes you run out of numbers, so you can't just leave it blank. You got to know that there's something there, which is a 1. So for now, let's just put a 1 there. Same thing here. 5, 5, they cross out and they become 1s. And then there's a 5 left over. Now I'll solve. 1 times 5 is 5, and 1 times 1 is just 1. And 5 over 1 is simply just 5. Now we're going to go over the shortcut. Whenever you're dividing the same base, so they have to be the same again, technically, you subtract the exponents. And 3 minus 2 is 1. And my answer would be 5 to the first power. That's literally the same answer I got here, right? I just got 5, I get that. But if 5 doesn't have an exponent, I can always give it that invisible 1. So I get the same answer. So please understand, when they have the same base, you technically subtract the exponents if there's division. So example 10, right? First thing I'm going to do is, I'm writing this as a fraction. So it's 2 over 9 divided by 2 over 6. When you're dividing the same bases, technically you subtract the exponents. Keep the base the same, so it's 2. And then 9 minus 6 is 3. So my answer is 2 to the third power. The fraction method not only helps you understand this lesson, but it will also help you understand what happens if the denominator has a bigger number. And it'll help you understand how that changes your answer a little bit. So please, moving forward, do it the fraction way. Letter B, same thing, right? Very first thing I'm doing is the fraction method. Parentheses, -7 to the 9th, and -7. Because the -7 on the bottom doesn't have an exponent, I'm giving it a 1. Because you're dividing the same base, you technically subtract the exponents. So I'll leave my base as -7. And then 9 minus 1 is 8. Now before you're like, whoo, that was hard, I'm done. No, you're not. Remember, sometimes you got to stop and be like, wait a second, I think there's an extra step here. See, in 2 to the third power, you're done. But here, your exponent is technically even, right? 8 is an even exponent, which means that the negatives cancel out. So my answer is technically 7 to the 8th power, or parentheses 7 to the 8th power. Either one, once again, is correct. But it has to be one of these two. Please make sure you take that extra step, or the whole thing is wrong. Okay, letter C. I'll write as a fraction first. 3.5 to the 8th power over 3.5 to the 6th power. Because bases are the same and I'm dividing them, technically I subtract my exponents. So my final answer is 3.5, and then 8 minus 6 is 2. And I'm done. So go ahead and do these three on your own. But number 11, you don't see an exponent, so don't forget what you have to do, what number to give it before you solve anything. Same thing, I'm writing it as a fraction first. Y to the 8 over y to the third. I feel like some of you are always going to be like, oh, just the one with the bigger exponent goes on top. No, just know that the number that I read before the division symbol goes on top. It just happens to be a coincidence right now that every number that you read before the division symbol is the one that has the bigger exponent. But that can change, right? Later on, you might see like y squared divided by y to the 5th, which means that the bigger exponent's on the bottom and not top. So just please keep that in mind. Okay, same thing as before, right? Same bases, you're dividing, so technically you subtract the exponents. Answer is y to the 5th power. This one, same thing, negative x with parentheses, 6 over negative x with parentheses squared. Negative x, 6 minus 2 is 4. 4 is an even exponent, which means that the negatives cancel out. So my final answer is x to the 4th power. Try these two on your own. Be mindful if your base is a negative and there's parentheses. When your base is a negative and there's parentheses, ask yourself that whole, is the exponent odd or even? If it's odd, leave it alone. If it's even, then the negatives cancel out. You got to make your base positive. All right, example 12. Same thing, right? We're going to write it as a fraction bar instead. So h to the 6, k squared, divided by, and then h to the 5th, and k. First thing I do after rewriting it, of course, is if I see a letter with no exponent, or if I see a number with no exponent, I'm giving it an exponent, giving it that magical 1. Try not to think of it as one problem. In your mind, separate it. Think of it as the h's first, and then the k's, and then just put it together. So here you're dividing. So technically, you're subtracting the exponents. 6 minus 5 is 1, so it's h to the first power. And then I'll do the k's. Once again, you're dividing the k's, so technically you're subtracting the exponents. 2 minus 1 is 1, so it's k to the first. Listen, there's your answer, right? Because simpler is better. Some of you might just write hk. Because if the exponents are 1, technically they're invisible. You don't really need it. So this is actually a better answer. Both are correct. I wouldn't take off for either one, but this is definitely the better answer. Okay, B, 28, m to the 7th, n to the 4th, 7, m to the 3rd, n squared. But, in your mind, you got to practice separating them. You're not seeing this as one problem. Try to separate it so that you can see as multiple problems. It might sound like it's harder at first, but it's actually a lot easier. One thing I do want to make clear is that you can use colored pencils, you can circle it the way I'm doing it too, so you don't have to just try separating in your mind, right? There's visuals you can do to help separate it. The first scenario is saying 28 divided by 7. Again, 28 divided by 7, these are not exponents. These are called coefficient numbers. The font is bigger. So you're not subtracting it. I have so many kids who are like, oh, this whole lesson's about subtraction. So I'm going to subtract 28 minus 7. No. You only subtract exponents. And you only subtract exponents when you're dividing the same base. So please understand there's ifs in this. Right now, 28 and 7, they're not exponents. So I'm not subtracting it. I'm literally doing what it says. 28 divided by 7, which is 4. M to the 7th divided by m to the 3rd. The 7 and the 3 are exponents. The tiny little numbers. So here I can go ahead and use that rule now. I can subtract 7 and the 3 to get 4. So it'll be m to the 4th power. And the same thing for the n's, right? The 4 and the 2 are exponents. And the bases are the same. So I can use the rule again. 4 minus 2 is 2. So it'll be n to the 2nd power. Okay, right? Look at this. Overwhelming. Overwhelming. I get that. Take it step by step. Break them apart. And you'll see how this is not as hard as it looks. Do these two on your own. All right, part C. So part C, if you think about it, right? Part A was all about multiplying. When you multiply the bases that are the same, you add the exponents. Part B was, if you're dividing the same bases, technically you subtract the exponents. Part C is you're doing both now. You're doing both kind of at the same time, right? And I say kind of because I do have you separated where you do multiplication first, and then you focus on the dividing. Even though technically you can do either or first. Focus on the multiplying first. So what does that really mean? Focus on the top and bottom first. So you're looking at A, and you're getting overwhelmed, but you're not focusing on the bottom at all. Just focus on the top, solve it, and put it here. Then focus on the bottom and put it here. And then we'll take it from there. Okay? So step 1, once again, we're focusing on the top. Now the top, all the bases are the same numbers. I'm going to keep it the same. So my answer is going to be 4. And because I'm multiplying, right, in between each of these 4s is a multiplication symbol. So because I'm multiplying, technically, I'm adding the exponents. 2 plus 7 is 9, plus 1 is 10. My answer is 4 to the 10th power. Okay, you're done with step 1. Nice job. Now let's move on to the next one. Now we're focusing on the bottom. We don't care about the top anymore. Now on the bottom, one number doesn't have an exponent. It's the middle one. So I'm going to give that middle 4 a 1. I'm leaving it as 4. And then because in between each of the numbers is multiplication, I'm going to add the exponents. 3 plus 1 is 4, plus 4 is 8. Now I have 4 to the 10th over 4 to the 8th. I am not done with this answer, right? So the operation between the two 4s is division. So when you're dividing the same base, technically you subtract the exponents. 10 minus 8 is 2. So 4 remains the same, but 10 minus 8 is 2. And my answer is 4 squared. It's only in this one packet, and it come out well, the exponents. So I'm just going to rewrite it. I recommend you doing the same. So it's 1/4 in parentheses, and that exponent's 3. Then it's 1/4 in parentheses, and then it's 1/4 in parentheses again, but the exponent is 2. And then on the bottom, they're all just 1/4 with no exponent. All right, step 1. Give numbers that don't have exponents, exponents. So I'm going to give a little 1 here, a 1 here, 1 here, and yes, a 1 here. And then I'm going to solve. Looks very overwhelming at first. At first you're like, this is impossible. I can't solve this. But then you're going to calm down. You're going to be like, oh wait, what did Mr. Deacon say again? Oh, that's right. Let's focus on just the top first. Just the top. What are baby steps? They all have the same base. And I'm multiplying, because there's multiplication in between each base. So technically I'm going to add the exponents. So it's going to be 1/4. And then 3 plus 1 is 4. Plus 2 is 6. Done. Don't need this anymore. Now I'm going to focus on the bottom. Once again, the bases are the same. Technically, in between each 1/4 is multiplication. So I'm going to add the exponents. And it's going to be 1/4. And 1 plus 1 plus 1 is 3. Done with this. Now this looks like part B. In between the 1/4, right, in between this 1/4 and this 1/4 is a division symbol. So here we're not adding the exponents. Here we're going to subtract the exponents instead. And 6 minus 3 is 3. Letter C is a hard one. So letter C, I'm actually going to rewrite it. And I'm going to rewrite it all here. All right. So listen, this one's going to be a hard one. So I'm first going to solve the top and put it obviously on the top here. Okay. What makes this so hard is that some numbers are coefficient numbers. That means the big font. And some are the tiny little numbers, which is the exponents. And I get a lot of kids who just get confused with the difference. When to do the shortcut and when not to. 3, 5, and 6 are all big numbers. So you're not doing any shortcut. It says 3 times 5 times 6. So 90 is on top. Then you have x to the 4th and x to the 6th. X to the 4th times x to the 6th, because they're exponents and their bases are both the same. Add, and that'll be x to the 10th. And then of course this y to the 5th has no buddies on top. So I'm just going to bring him down and it'll be y to the 5th. And you're done with your numerator. The big coefficient numbers, multiply. 2 times 3 times 5, and you get 30. This y doesn't have an exponent, so we're going to give it a 1. And y to the 1st times y to the 3rd is y to the 4th. Look what I did visually though. I put the y to the 4th directly underneath the y to the 5th. Make sure the x's are, are on top of each other and the y's are on top of each other. And the coefficient numbers, the big font numbers, are on top of each other. X squared doesn't have a buddy, so I'm just going to bring him down. Try separating them. Big coefficient numbers, exponents, the big coefficient numbers, you can't do the shortcut. 90 divided by 30, which is 3. Then you're going to do x to the 10th divided by x squared, which is x to the 8th. You're going to do y to the 5th divided by y to the 4th, which is y to the 1st. Once again, it's division that's in between each of these terms. And that's why you're subtracting the exponents or dividing the actual coefficient numbers, right? It's always what's in between them. Now, the only other thing I want to explain, and this one is just for more of my advanced students, I could have gotten the 3 much easier than the way I explained it. Now, I got 3, once again, because I multiplied 3, 5, and 6 to get 90, and then 2, 3, and 5 to get 30, and I did 90 divided by 30 to get 3. But what you could have also done, and this is why we do those comp packets, you could have simplified before you multiplied ahead of time. It works here as well. So for example, this 3 could have crossed off with this 3. This 2 goes into 2 once. 2 goes into 6 3 times. And then this 5 would have canceled out with this 5. And then if you look at all the big numbers, the only number that's left that's a big number was 3. So that whole simplifying before you multiply works here as well. It does not work with the exponents. It only works with the coefficient numbers. So let's keep that in mind. Okay? Try these 3 on your own, and then we'll do one word problem. There are approximately 10 to the 25th power water molecules in a liter of water. Patrick has 100 liters of water. How many molecules are there in all? Write your answer in exponential notation. You have 1 liter A liter means 1. Listen, this is my amazing artwork right now. This right here represents 1 liter. And we have 10 to the 25th water molecules in that 1 liter. However, Patrick doesn't have a liter. He has 100 liters. So literally there's 100 of these. I'm not going to write out 100, but I think you guys understand what operation you have to do. Because there's 100 of these guys right here, we have to multiply. We got to multiply 100 by 10 to the 25th power. So once again, they want our answer exponential notation. I mean, technically, you could just put this in your calculator and you're done. 100 times 10 to the 25th power, call it a day. But instead, what they want you to do is, they want you to first convert them so that they both have the same bases. There's a 10 here, so we're going to convert this 100 to a 10. So it'll be 10 to the second power. How did I get that? Well, very simple. 10 to the second power equals 100. So it's 10 to the second power times 10 to the 25th power. Now that they have the same bases, now I can do that shortcut. When you're multiplying numbers that have the same bases, technically you add the exponents. And my answer is 10 to the 27th power. And then of course you can write it out where it's molecules. Okay, try number 19 on your own. The only thing is, I know it might be a little difficult to read the numbers. This right here is 10 to the 8th power, and this right here is 10 to the 10th power. The only thing I'm going to help you with, it does say how many times. So I'll give you a little bit of a hint. How many times does 2 go into 8? Try thinking of what operation you're doing to solve that, right? How many times means division. So they want you to divide, and they kind of give you that hint here anyway. They want you to divide to get your answer. But please keep in mind, when you're dividing the same base, technically, what do you do with the exponents? Done. Read it, solve it on your own, you got this.